Okay, here we are in section 4.2 on maximum and minimum values. Here are two sample problems from the book. The first one is a real straightforward graph. They just want you to have a really clear visual sense, and the words suggest exactly what we're going to try to emphasize here. Absolute maximum or absolute minimum values, as it sounds, are the values that are the highest when you consider the entire domain, or the lowest when you consider the entire domain. And it's stated in the book really clearly. You're talking about, an absolute maximum is a value for which any x value is going to be less than or equal to that particular vertical or y value or function value. All right, so looking at this graph, what's the absolute maximum? Well, as you sweep down, bonk, you hit there, okay? That is going to be the first point you touch, so that would be the maximum value. If you're just counting squares, each square has a value of 1. So that is an absolute maximum value is equal to 4. All right, the absolute minimum value, lowest point, is 0. But now local maximum, sometimes they're called relative maximum minimum, is just a point where if you go a little bit to either side, okay, you're going to be finding a value that's greater if it's a local minimum or less if it's a maximum. So again, pretty clearly this is a local minimum value, all right, because on either side it's greater. So we would say at x equals 2, all right, and another local minimum value is when x equals 5. And that's the absolute minimum, so we don't need to touch that. These are minimum values. Okay, maximum values are going to be right here. 1, 2, 3, 4, that's 5, so it's 6. X equals 6, and also x equals 4. These are local maximum values, all right? Now, you can state what the actual values are, of course. At 4, the maximum value is 4. At 0, the minimum value is 0. At 2, the minimum value is 1. And for the local minimum is 1. And at 5, it's 2. So the values that correspond to the x values can be plugged in. But we're often interested in more where you are in x to get those local maximum or minimum values. All right. So another problem I want you to look at here as an example is problem 27 from the book. All right. And find the critical number. Okay. Critical numbers are numbers at which the derivative is equal to 0. So we're really finding when is the derivative equal to 0. All right. So let's find the derivative. When I do that, I get 12t to the third plus 12t to the second minus, guess what, 12t. So we'll set that equal to 0, all right? I think it's helpful perhaps to think about, we've got a function and we're really looking at when is the derivative going to give us 0. I did punch this into the calculator here, and so if I turn that on, there's the function, okay? And if I get lucky, I'll find it in the standard Zoom 6 feature, and I can basically see it there. I would like to see a little less of the wings and a little bit further down, that's minus 10, and maybe a little bit less here. It's pretty straightforward, so I'll tweak it a little bit. I'll go minus 5, and then to plus 5. I won't change the scale. I think I need to see about to minus 15, and maybe to a plus about, 6, something like that. And hopefully this is a little bit better view, and it is. Okay, so I can see that I'm going to have a derivative value that's going to be 0 about here. Looks like I'll have another local maximum at 0, and then a local minimum here a little bit less than maybe 1. All right, so just keep that in mind. So when is this equal to 0? Well, I can factor out a 12t, and what's left behind is t squared plus t minus 1, all right? Well, when you factor something, you can say, well, when is this equal to 0, and when is this equal to 0? This is when t is equal to 0. I'll have a critical number there. This if I could factor it, it'd be great, but there's no way I can have two numbers multiply to make -1 that add up to make 1. That would mean I'd need something like 1 times -2. So this is a quadratic formula problem with A, B, and C. A equals 1, B equals 1, C equals -1. That's about as simple as it gets. So it's minus B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So that's very straightforward. That's actually, I think, the golden rectangle. Whoops, have I been off the screen all this time? That's a bit of a pain. Sorry, I've been going through just the simple quadratic formula there. And this will give me then -1 plus or minus the square root of 5. Negative and a negative is positive. 1 plus 4 is 5, all over 2. And so you can leave it like that in exact terms right there. You're going to get two different critical numbers. This is going to be approximately, that's about 2.25. This is going to be about 0.618. And when that's a negative, negative about 2.2 something. Okay, so there are my critical values, all right? That's in exact terms. Let's just pretend, looking ahead, this is where we're going with this, is suppose we're saying that this function is limited to a domain of, say, -3 to 2 over that interval. Find the absolute and local maximum and minimum points, all right? So clearly I'm going to have endpoints. 2, there's going to be an endpoint up there somewhere. At -3, there's going to be an endpoint up there somewhere. And I'm going to have local maximum values there and minimum values there. All right, that's where the critical points come in, critical numbers. So let's find that. The first thing you're going to do is you're going to plug in these values to find the endpoints. So what is f of -3, and what is f of +2? +2, all right? And an easy way to do that on your calculator, I bet you know this, is to hit the trace button and then type in the value. And you'll see if I type in -3 and hit enter, that gives me 81. I can definitely do it longhand, but this is pretty easy. And if I type in 2, hit enter, I get 56. Okay, so that means that on the left-hand side here, it goes up to 81. On this side, it only goes up to 52. So my maximum value in the whole function over this domain is going to be that. Then the local minimum value will be at f of 1, -1 minus radical 5 all over 2. And what will that value be? If I type that in, if I type in parentheses -1 minus second root 5, close parentheses, divided by 2, I should get an answer. And there it is at -1.6. That doesn't look right. Oh yeah, that is right. Sorry, 1.6. Sorry, I wrote that wrong over here. That should be -1.618. I get a value. Now this is -12.05, so that's how far down I go when I'm at that local minimum. I'm going to skip this because it's pretty clearly that when I'm at 0, the value function is 0. That's this one right here. So this is local min, and then f of 0 is a local max, and then finally f of -1 plus radical 5 over 2 is also, as you can see right there, 0.6 will be a local minimum. Okay, so you try the endpoints, and this is our absolute max. And then where is our absolute minimum value? Oh my goodness, it's this one. So I wrote local, but this is absolute. Sometimes you have to do a rough draft and catch yourself. That's the absolute minimum value of the function there, okay? And we're done with that. Good luck.